Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to be working on problems from a practice test that includes topics that I've covered over the last week. Again, over the last week, I've covered fraction word problems, absolute value equations, prime numbers, system of equations, and classifying numbers. If this is your first time finding my channel, I want to stress this. These topics do not cover everything that shows up on the ASVAB. Instead, this practice test is a review of just these topics I've covered over the last week and a half. As always, I strongly encourage you to pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. In the description of this video, there are going to be timestamps that are associated with each question, and next to the timestamp, there's going to be the topic that the question's testing, as well as a link to a video in which I discuss that topic. So if at any point during this video you feel as if you need more help, check the description of this video, and there you'll find the links to the additional resources. So all that finally being said, let's go ahead and get started with today's video. Again, on the ASVAB, you're not permitted to use a reference sheet or a calculator, so don't use any of those resources as you work out these questions. All right, this first question says, at a military academy, students spend 1/4 of their time during the day eating and sleeping, 3/5 of their time in class, and 1/12 studying. The rest of their time is considered free time. What fraction of their day is considered free time? So for this one, we're going to have to do some subtraction involving fractions to figure out how much free time they have during the day. So again, we're talking about one day here, and according to the problem, they spend 1/4 of that day eating and sleeping, 3/5 of it in class, and 1/12 of it studying. By subtracting 1/4, 3/5, and 1/12 from 1, we'll figure out how much free time they have during the day. That said, you can see we are subtracting fractions here. And in order to add and subtract fractions, your fractions have to have the same denominators. In this case, we don't have a denominator for 1. We have a denominator of 4 and 1/4, 5 and 3/5, and 12 and 1/12. So our first objective here is to rewrite these fractions such that they all have a common denominator. And for 1 here, we can quickly rewrite that as a fraction by placing it over 1. So 1 is the same as 1 over 1, and that's minus 1/4 minus 3/5 minus 1/12. So we're trying to identify a common factor between 4, 5, and 12. Well, I know 4 and 5 both go into 20, but 12 doesn't go into 20. 4 and 5 both go into 60, and 12 also goes into 60. I could work that off to the side, but at this point, you should be fairly confident in your ability to identify common denominators without having to write it off to the side. So that said, we're going to rewrite these fractions with a common denominator of 60. Let's go ahead and get that set up as our next step here. And we're going to rewrite all of them with a common denominator of 60. To write 1 as 60, we would have to multiply it by 60, and we're also going to have to do that to its numerator. Again, 1 times 60 is 60. 60 times 1 is 60. So as we can see, 1 over 1 is the same as 60 over 60. To write 4 as 60, we're going to have to multiply it by 15. Again, 4 times 15 is 60, and we're also going to have to do that to its numerator. 1 times 15 is 15. To write 5 as 60, we're going to have to multiply it by 12. Given that 5 times 12 is 60, then we're also going to have to do that to its numerator. 3 times 12 is 36. To write 12 as 60, we have to multiply it by 5, and we're also going to do that to its numerator. 12 times 5 is 60, of course. 1 times 5 is 5. All right. Now that we've rewritten these fractions such that they all have the same denominators, we can combine them into one big fraction like this. And it's all going to be over 60. We're going to have 60 minus 15 minus 36 minus 5. And what I'm going to do very quickly is I'm going to combine these three numbers right here to make the math a little bit easier. So I'm going to take uh, 15 plus 5 plus 36. 5 plus 5 is 10. 10 plus 6 is 16. So we're going to drop down to 6 and carry a 1. 2 plus 3 is 5. So this becomes 60 minus 56 over 60. And we can work this out pretty quickly. 60 minus 56 is 4. Of course, this is over 60. And of course, we can reduce this since 4 and 60 have a common factor of 4. So that we're going to reduce this by dividing 4 and 60 by 4. 4 divided by 4 is 1. 60 divided by 4 is, as we saw over here, 15. So the answer to this one is B. They have 1/15 of their day for free time. And we found that by subtracting these fractions from 1. All right, so that's that one. Pretty challenging, but nothing too difficult. Let's go ahead and move on now. All right, number 2 says solve the equation for x. We have the absolute value of 3 plus x minus 5 equals 4. All right, so the very first thing you want to do when you're dealing with absolute values is you want to isolate the absolute value on one side of the equal sign. So let's go ahead and do that first. Again, I'm going to start by copying this one down. We have the absolute value of 3 plus x minus 5 equals 4. Again, we want to isolate this absolute value. So I'm going to add 5 to both sides. And this will become absolute value of 3 plus x equals 4 plus 5, which is 9. All right, as far as solving absolute values go, when you have an absolute value equal to a positive number, that's going to prompt you to get rid of your absolute value bar. So we're going to have 3 plus x. One of them is going to be set equal to that number. So 3 plus x equals 9. And then the other one, 3 plus x, is going to be set equal to the opposite of that number. So the opposite of 9 is negative 9. And now we're going to solve accordingly. Let's do these one at a time. I'm going to work on this one first. To solve for x here, we're going to subtract 3 from both sides. This is going to cross out, leaving you with x equals 9 minus 3, which is 6. So that's one of our solutions. Over here, we're going to subtract 3 from both sides. This will cross out here, leaving you with x equals negative 9 minus 3. That's going to be negative 9, negative 10, negative 11, negative 12. So for this absolute value equation, there are two solutions, notably 6 and negative 12, which means the correct answer is B. All right, so that's that one. Number 3 says, which of the following numbers is a prime number? We have 312, 105, 939, 499. I will say this, I can identify the prime number already because I know how to look at numbers and run divisibility checks to determine if they're prime or not. So in my video in which I discuss how to quickly determine if a number is prime, I showed you how to perform divisibility checks. So let's go ahead and do that here. And we're going to do it for each of these. Again, we have 312. We'll perform divisibility checks for 2, 3, 4, and 5. We have 105. We're going to perform divisibility checks for 2, 3, 4, and 5. We have 939. We're going to perform divisibility checks for 2, 3, 4, and 5. And finally, we have 499. So we're going to perform divisibility checks for 2, 3, 4, and 5. Now you might be asking yourself, what are these divisibility checks? Well, there are rules regarding divisibility that will tell you if 312 is divisible by 2, 3, 4, or 5 without having to do any work whatsoever. And if a number is divisible by something other than 1 in itself, it's not prime. So in other words, if 312 is divisible by 2, 3, 4, or 5, it's not a prime number. So to run a divisibility check for 2 here, you look at the last digit in the number. So in 312, the last digit's right here. And if that digit is even, then the number is divisible by 2. Since 2 here is even, I can say yes, 312 is divisible by 2, which means it's not prime. So right then and there, I eliminated 312 as being prime since it's divisible by more than just 1 in itself. All right, let's take a look at 105. Um, Again, just by looking at these numbers, I can tell if it's prime or not. And in this case, I looked at the last digit of 105. Well, I know the divisibility test for 5 says this. If the last digit in a number is 0 or 5, then it's divisible by 5. In this case, we have a last digit of 5. Therefore, I know 105 is divisible by 5, and therefore it's not prime. All right, this one's a little bit more tricky, so let's go through our divisibility test until we find one that works. So to check for divisibility of 2, we look at the last digit. If it's even, then it's divisible by 2. If it's not even, then it's not divisible by 2. 9 is an odd number, therefore I know 939 is not divisible by 2. So let's move on to 3. To run a divisibility test for 3, you sum the digits in the number. So we're going to take 9 plus 3 plus 9. And if that sum is divisible by 3, then the number itself is divisible by 3. So let's sum these. 9 plus 9 is 18, 19, 20, 21. So the sum of 9 plus 3 plus 9 is 21. 21 is divisible by 3. 21 divided by 3 is 7. And since the sum of these digits is divisible by 3, I also know 939 is divisible by 3. And since 939 is divisible by 3, it's divisible by more than just 1 in itself, which means it's not prime. All right, let's check 499. At this point, you should say 499 is the correct answer because we've checked all the other ones. But let's just quickly run our divisibility test. Again, for 2, we're looking at this last digit. If it's even, it's divisible by 2. If it's odd, it's not divisible by 2. 9 is odd, so I know 499 is not evenly divisible by 2. To check if it's divisible by 3, we sum the digits in the number. So we're going to do 4 plus 9 plus 9. And if the sum of those digits is divisible by 3, then the number itself is divisible by 3. 9 plus 9 is 18, 19, 20, 21, 22. 22 is not divisible by 3. Therefore, I know 499 is not divisible by 3. To check if a number is divisible by 4, you look at the last 2 digits in the number, and if the last 2 digits are divisible by 4, then the number itself is divisible by 4. 99 is not divisible by 4, so I know 499 is not divisible by 4. And finally, let's look at 5 again. To check if a number is divisible by 5, you look at the last digit, and if it's a 0 or a 5, that number is divisible by 5. Our last digit's a 9, which is neither 0 nor 5, so we know the 499 is not divisible by 5. And I'm satisfied with my divisibility checks enough to say that 499 is a prime number. So that's that one. All right, so number 4 says, what type of number is negative 12 over 4? All right, so let's go ahead and simplify this first. We have negative 12 over 4. That is to say we have a negative divided by a positive, so we know our result's going to be negative. 12 divided by 4 is 3. So in reality, we're talking about the number negative 3, and we want to classify it. Well, in a video I uploaded yesterday, I talked about using a mnemonic device to help you remember how to classify numbers. And that mnemonic device was NWIR, NWIR bar I. And this says natural numbers, whole numbers, integer, rational, irrational, and then, as I mentioned in that video, all of these numbers are real numbers. What is a natural number? A natural number is your counting numbers, such as 1, 2, 3, 4, and 5. What's a whole number? A whole number is your counting numbers plus 0, so 0, 1, 2, 3, 4, and 5. An integer is a whole number plus negative, so -3, -2, -1, 0, 1, 2, 3, 4, and 5. And that's what we have here. -3 is an integer, so I'm going to say it's an integer. And the way this mnemonic device works is like this. If you identify a number, that number is also everything to the right until you hit this bar. So we know -3 is an integer, but that said, we're looking to the right and we know it's also rational. And what's more, all of NWIR is a real number. So -3 is an integer, it's rational, and it's real, which is answer choice D here. All right, so again, I put this bar here because let's say I had a natural number. Again, a natural number is everything to the right. A natural number is a whole number, it's also an integer, and it's also rational. So again, that's how that mnemonic device there works. It's very helpful. So that's that one. All right, number 5 says solve the following system of equations. We have 2x plus 5y equals 16 and 4x plus 10y equals 32. I'm going to start by copying this off to the side. We have 2x plus 5y equals 16, and then we have 4x plus 10y equals 32. In order to solve a system of equations, you want to use one of two methods. You want to use the substitution method or the elimination method. I prefer to use the elimination method, and it says multiply either one or both of these equations by a constant, such that when you add the equations together, one of the variables is eliminated. So I'm going to take this top equation and I'm going to multiply it by -2. And when I do that, this will become -2 times -2x, which is -2 times 2x, which is -4x. When I add -4x to 4x, the x variable is eliminated. So let's go ahead and do that and see what happens. Again, we're going to take this -2, we're going to distribute it here, here, and here. And let me move over to the side here so we can have some more room to do that. -2 times 2x is -4x. -2 times positive 5y is -10y. And -2 times 16 is -32. Again, we're adding that result to this bottom equation, notably 4x plus 10y equals 32. Let's add these together. All right, so we have -4x plus 4x, which is 0. That variable is eliminated. But that said, we have -10y plus 10y. So that's eliminated as well. So we have nothing on this left-hand side of the equal sign. What about over here? We have -32 plus 32, which is 0. So we've reached a point where we have a true mathematical statement that is 0 equals 0. But we should have something like this: x equals 3 or x equals 2. Well, whenever you reach a point when you're solving a system of equations where you have a true mathematical statement and you have 0 equals 0, that should tell you that these two lines are the same, which means that there are infinitely many solutions to this system of equations. Okay, so that's that one. And again, in my video that I uploaded this week, I showed you how to graph these. And if you were to graph these two equations, they would sit right on top of one another. Okay, so that's that one. All right, number 6 says solve the equation for x. We have the absolute value of 2x minus 1 plus 10 equaling 2. So I'm going to copy this one off to the side to start. Again, we have the absolute value of 2x minus 1 plus 10 equaling 2. Again, before we make any judgments whatsoever about this absolute value equation, we want to get the absolute value by itself on, in this case, we're going to get itself on the left-hand side of the equal sign. So to do that, I'm going to subtract 10 from both sides. This will cross out here, leaving you with 2x minus 1 over here equals 2 minus 10, which is negative 8. All right, so this is where your knowledge of solving absolute value equations is very important. You could never have an absolute value set equal to a negative. There's no value that you can plug in for x such that this will ever become a true statement. So whenever you have an absolute value isolated and equal to a negative, there is no solution to it. All right, so the answer to this one is D, no solution. All right, so number 7 says solve the following system of equations. We have 2x plus 3y equals 10 and 2x plus 3y equals 12. I'm going to start by copying this one off to the side. Again, we have 2x plus 3y equals 10. And then we have 2x plus 3y equals 12. Again, there are two methods to solve systems of equations. You can either use the substitution method or the elimination method. Again, I prefer the elimination method. So I'm going to multiply one or both of these equations by a constant such that it will eliminate one of the variables. And more specifically, I'm going to take this top equation and multiply it by negative 1, because when I take negative 1 and multiply it by 2x, that becomes negative 2x. And when I add the two equations together, the x variable will go away. So let's go ahead and take this negative 1 and distribute it here, here, and here. So negative 1 times 2x is negative 2x. Negative 1 times positive 3y is negative 3y. And negative 1 times 10 is negative 10. We're going to add this to the second equation. So that's 2x plus 3y equals 12. Let's add these together. Negative 2x plus 2x is nothing. That's eliminated. That said, we have negative 3y plus 3y. That's also eliminated. So on this left-hand side of this equal sign, we have nothing or 0. Negative 10 plus 12 is 2. All right, so we can see that as we're trying to solve this system of equations, we've got this scenario here, 0 equals 2. That's an untrue mathematical statement. 0 does not equal 2. And in light of that, we know that there is going to be no solution to this system of equations. Again, previously, we saw 0 equals 0, which was a true mathematical statement. Therefore, we concluded that there were infinitely many solutions to the system of equations. In this case, we have an untrue mathematical statement, so there is no solution to this system of equations. What's more, in that video I uploaded this week, I showed you that in cases like this one, you have a set of parallel lines that never intersect. And again, the solution to a system of equations is the point at which the lines intersect. In this case, we have parallel lines and they're never going to intersect. So there's no solutions. And so that's that one. All right, finally, we have 8, and it says, what type of number is pi? All right, so again, if it's helpful, you can use my mnemonic device, NWI, N-W-I-R, big bar, I, and then as we know, these are all real numbers. So the thing about pi is this. For the ASVAB, you're going to approximate pi as 3.14. That's not actually what pi is. That just enables you to do the math, the arithmetic by hand. Pi, as I'm sure some of you know, is the decimal 3.14, and it never ends and it never repeats. And there's no way what's more to write it as a fraction. So let's go through these again real quickly. Natural numbers, 1, 2, 3, 4, 5, 6, and so on. Whole numbers, 0, 1, 2, 3, 4, 5, 6, and so on. Integers, negatives, 0, and natural numbers, so -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. Rational numbers. A rational number is a terminating decimal, and terminating decimals can be expressed as fractions. There's no way you can ever express pi as a fraction. Therefore, pi is irrational. But that said, again, all of near we are real numbers. So pi is irrational, but at the same time, it's also real. So pi is an irrational and real number. All right, so that's it for this video. Was very short. Again, I was just trying to give you a review of the topics I've covered over the last week and a half. These topics are not deal breakers. That is to say, if you don't know how to tell if a number is prime, you're not going to fail the ASVAB. But that said, since the ASVAB is a computer adaptive test, you want to get as many of these questions right so that you can get as high as an AFQT score as possible and qualify for the most number of jobs. As always, you're more than welcome to leave feedback in the comment section below. Again, if you struggled with anything I did in this video, take a look at those videos I've uploaded this week. Some of these topics are very difficult to explain, so you would have to watch that video in full to grasp the entire concept. If you find my content helpful, please consider subscribing to my channel. But on that note, I'm going to go ahead and cut you loose.
Konnichiwa.